Hello everyone, I am Dr. Munish Bharadwaj from School of Engineering and Technology of IGNOU. Today we will discuss about cement. What is cement? How it is manufactured? Then what are the important properties of cement? All these we will discuss in this lecture. Let us begin with what is cement. Cement is a product manufactured by burning and crushing to powder an intimate and well-proportioned mixture of calcareous and argillaceous materials. These are the two different types of materials which are used for manufacture of cement. Ordinary Portland cement is the most commonly used cement in construction. The name of Portland cement is derived from its similarity to Portland stone, a type of building stone quarried on the Isle of Portland in Dorset County of England. Other type of cements which are used in construction industry are low heat cement, rapid hardening cement, high alumina cement, white cement, blast furnace slag cement, sulfate resisting cement. Now let us see what are the factors for selection of type of cement. First is required strength of concrete structure, that how much strength of concrete we want. That will decide the selection of the type of cement. Let us see the manufacturing process of cement. First of all, let us see what are the raw materials for manufacturing of cement. First is calcareous materials. What are these calcareous materials? These calcareous materials are the materials which contain calcium or lime as their major constituent. For example, limestone, marl, chalk, shell, etc. These materials provide the required proportion of lime to the cement. Means these are the main source of lime for preparation of cement. Second type of material are argillaceous materials. These are the materials which contain alumina as their major constituent. For example, shale, clay, laterite, etc. These materials provide the required proportion of silica, aluminium, oxide of iron, etc. to the cement. Now let us see what is the process basically. What happens basically when we are manufacturing the cement. In the process of manufacturing of cement, the grinding of the raw materials is done first. Raw materials, as we saw here in the last slide, that calcareous materials and the argillaceous materials are the raw materials. They are first ground. Then mixing of these materials is done intimately in certain proportions. It is not that you can just mix any amount of argillaceous material and any amount of calcareous material. A certain proportion is used for mixing them, and then burning in a kiln is done at a temperature of about 1500 degrees centigrade, very high temperature. Now the materials sinters and fuses to form nodular shaped clinker. A clinker is formed on burning of these raw materials. Then clinker is cooled and ground to a fine powder with addition of about 2 to 3% of gypsum. Here is the gypsum plays very important role. I'll tell you later. Now the product obtained is the Portland cement. So this is the process of manufacturing the Portland cement. Now, for manufacturing of cement, we follow the two different processes. One is wet process, another is dry process. In wet process, what we do, mixing and grinding of raw materials is done in wet condition. Means they are taken and water is added and then grinding is done. So a slurry is formed in this process. In dry process, what we do? Mixing and grinding of the raw materials is done in dry conditions. Means there is no formation of slurry in case of dry process. The main difference here is the energy required basically. That how much energy or the fuel is required in the two processes. In case of wet process, basically more fuel is required because slurry has lot of water, about 35 to 50% basically. So for evaporating this water, more energy or the more fuel is used basically. Now let us see what are the details of the wet process. First, limestone is crushed to smaller fragments, then taken to a ball or tube mill where clay or the shale is mixed with it and ground to a fine consistency of slurry with addition of water. Means after adding the water, the slurry is formed. Thus, this slurry is pumped to the slurry tanks where it is kept in a agitated condition by means of rotating arms with chains to prevent setting of limestone and the clay particles. Then what we do next is chemical composition of slurry is adjusted as necessary. Means if we see that what is the composition of this slurry, if something is lacking, we add into that slurry basically. So we correct the composition of the slurry. This corrected slurry is injected at the upper end of the rotatory kiln. What are the specifications of the kiln? The diameter of this rotatory kiln is generally varies 3 meter to 8 meter. Length varies from 30 meter to 200 meters. And this kiln is laid at a gradient. It is not horizontal basically. It is laid at a gradient of 1 in 25 to 1 in 30. This is the gradient basically. So this is, you can say, it is inclined basically. Now this refractory lining is provided on the inside surface of the rotatory kiln basically. And this kiln rotates at about 1 to 3 revolutions per minute about its longitudinal axis. About longitudinal axis, it is rotating basically. And rate of rotation is 1 to 3 revolutions per minute slowly. The portion of the kiln near its upper end is known as dry zone, where the water of slurry is evaporated. Because here the water of slurry is being evaporated, it is known as drying zone. As slurry gradually descends, goes down, there is a rise in temperature in the kiln. What happens then? Small lumps called the nodules are formed. Small lumps are formed from this material, from this slurry basically, and these nodules gradually roll down and passes through zones of rising temperature. As they go down, the temperature in the kiln is rising. So when they are passing through this kiln, the temperature is rising, and these balls or the nodules finally reach to the burning zone where the temperature is about 1500 degrees centigrade. And at this temperature the burning takes place. Now after this burning, what happens in this burning zone? That calcined product is formed and nodules now turns into small hard dark greenish blue balls. We get now at this stage hard dark greenish blue balls, which is known as clinker. So this is very important. Basically, what is clinker? Clinker is simply hard dark greenish blue balls basically, and which is obtained on burning of the calcined material basically. Now the clinker drops into a rotatory cooler where it is cooled under the controlled conditions. Now it has come out of the kiln. Now these balls will be cooled basically. Now these clinkers are finally grounded in ball mills and the tube mills. During the grinding, a small quantity of about 2 to 3% of gypsum, which acts as retarder, is added to increase the setting time of the cement. So this is the process of the manufacture of cement in wet process. Now let us see another process, how the another process of manufacture of cement works. Now dry process. In this process, what we do, raw materials are crushed dry and fed in correct proportions into the grinding mill. Now dry powder is further blended and corrected for its right composition and mixed by using compressed air. So compressed air is used to mix the different components of this powder basically. The aerated powder tends to behave almost like liquid, and in about 1 hour of aeration, a uniform mixture is obtained. So you obtain a uniform mixture after aeration of 1 hour of this powder basically. Then the sieved blended meal fed into a rotating disc called the granulator. Now it goes to the granulator. Now then the pellets of the blended meals are formed by adding water approximately 12% to permit airflow for exchange of heat for chemical reactions and conversion of the same into clinker. Means what we do here, that we will add 12% of water so that pellets of this blended meal are formed. Because if it remains in the powdered form, there will not be a uniform heating or burning of this material. So pellets are formed basically by adding 12% of water. So if at this stage you may say that this is dry process, why water? This is basically dry process because here we are adding very small amount of water of 12% to form the pellets basically. We are not forming slurry as we have done in case of wet process basically. So this remains in the almost dry form. We are forming pellets only by adding some water basically. Now after burning of these pellets, we get the clinker. The dry process is economical and the equipment used is comparatively smaller. The consumption of coal in this method is very low as compared to the wet process because we are burning here in a dry form basically. Now let us see what are the different oxides in the raw material of the ingredients of the Portland cement. This is very important basically, that what are different oxides. So let us see one by one. Chemical ingredients: lime, chemical formula CaO, calcium oxide. Commonly used percentage is generally 63% and range is from 60 to 65%. Silica, having chemical formula SiO2, it is used 22% in this total material and the usual range is 17 to 25. Alumina, which is having chemical formula Al2O3, 6% of it is used in this powder and general range is 3 to 8%. Iron oxide Fe2O3, 3% is generally used but range is 0.5 to 6%. Magnesia MgO, generally we use 2.5% and with range of 0.1 to 4. Sulfur trioxide SO3, 1.25% is used and general range is 1 to 3%. Alkalis, soda and potash basically, Na2O3 and K2O, generally the percentage is 0.25 and it range from 0.2 to 1%. So this is the, you can say the percentage wise oxides composition of the ingredients of the Portland cement. Now let us see what are the functions and effects of these chemical ingredients. First let us take lime. Lime is the major ingredient of the cement. It makes cement sound and also provides strength to the cement. Lime in excess, if we are using in excess, then lime makes the cement unsound and causes the cement to expand and disintegrate. The deficiency of lime will decrease the strength and cause the cement to set quickly. So these are the functions and the effects of lime. Let us see what are the functions and the effects of silica. Silica provides strength to the cement. Silica in excess causes the cement to set slowly. Let us see what alumina does. Alumina lowers the clinkering temperature, that at low temperature clinker formation may occur. It provides quick setting property to the cement, and if it is in excess, then it weakens the strength of the cement. Now let us see what are the functions of iron oxide. Iron oxide provides color, hardness and strength to the cement. It helps the fusion of material at lower temperature during the manufacturing of cement. What is the function of magnesia? Magnesium oxide provides color and hardness to the cement. Excess magnesium oxide remains in free state and makes the cement unsound, means it is harmful. Then sulfur trioxide. Sulfur trioxide makes the cement sound if present in very small quantity, but if it in excess, sulfur trioxide makes the cement unsound. Then what is the role of alkalis? Alkalis may be present in a very small quantity. Alkalis in excess causes efflorescence, means it is also harmful. Now let us see the chemical compounds of cement. That after burning of the raw materials, what chemical changes occur? What are the chemical compounds that are formed? Basically, this burning of raw material gives very complex compounds, very complex chemical compounds. These compounds are tricalcium silicate, 3CaO, SiO3, abbreviation generally we use C3S, and range in percentage is 25 to 50, but commonly its proportion is 40% present in the cement. Then dicalcium silicate, twice CaO, SiO2, generally we call it as C2S, range is 21 to 45%, but commonly it is found 30%. Tricalcium aluminate, 3CaO, Al2O3, commonly called as C3A, percentage range is 5 to 11, and generally we found that 11% is present in cement. Next is tetracalcium alumina ferrite, 4CaO, Al2O3, Fe2O3, but simply we call it as C4AF. General range is 9 to 14%, but commonly present is 11%. Other constituents and gypsum, range is generally 8%, and commonly also it is found 8% in the cement. Now let us discuss these chemical compounds of the cement. As I told you that after burning of raw materials, a lot of chemical changes occur in the raw materials basically, and very complex chemical compounds are formed. These are generally known as box compounds, and their order of formation of these box compounds is: first is C4AF, then C3A, then C2S, then C3S. This is the order of formation. Now let us see and know the properties of these different compounds. First, I take tricalcium silicate, C3S. C3S hydrates rapidly. It generates more heat of hydration, about 120 calories per gram. It is responsible for early strength development in concrete. Also, it is less resistant to sulfate attack. These are the properties of tricalcium silicate. Now let us see dicalcium silicate, C2S. Dicalcium silicate hydrates and hardens slowly. It generates less heat of hydration, about 60 calories per gram. It contributes a little in early strength development. It is responsible for ultimate strength development in concrete. Also, it is more resistant to sulfate attack. Now let us see tricalcium aluminate, C3A. Tricalcium aluminate causes initial setting of cement and it helps in early strength development in concrete. It generates large amount of heat of hydration, around 320 calories per gram. It hydrates very fast. It is the first compound to react with water. It is less resistant to sulfate attack and also it does not contribute much to ultimate strength development in concrete. Next compound is tetracalcium aluminoferrite, C4AF. C4AF is slow in reaction. It generates less heat of hydration. It is comparatively inactive and thus poor in early strength development. It does not contribute to develop ultimate strength as it has poor cementing value. It is less resistant to sulfate attack. C3S and C2S control most of the strength developing properties of the cement. The sum of their percentage range varies from 70 to 80%. Means these two compounds basically combined makes the 70 to 80% of the cement. By changing the relative proportions of these compounds, different type of cements can be manufactured. Now let us see the chemical composition of important cements. In ordinary Portland cement, C3S is 40%, C2S is 30%, C3A is 11% and C4AF is 10%. Whereas if you see for low heat cement, C3S is 25%, C2S is 45%, C3A is 6% only, C4AF is 14%. For rapid hardening cement, C3S is 50%, C2S 21%, C3A 9%, C4AF 9%. In sulfate resisting cement, C3S is 40%, C2S is 40%, C3A is 5% and C4AF is 9%. So that way you see that by changing the proportion of these compounds, percentage of these compounds, you can get different type of cement. Now let us see physical properties of the cement. Fineness of the cement, setting time, soundness of cement, compressive strength of cement, heat of hydration of cement and specific gravity of cement. These are the physical properties of the cement. Let us take one by one. Fineness. Fineness can be defined as the degree of grinding of cement. Fineness of cement is a measure of the size of particles of cement. For a given weight of cement, the surface area is more for finer cement than for coarser cement. Means fine cement will be having more surface area, coarse cement means coarse particles will be having less surface area. Finer the cement, the rate of hydration is more. Means rate of hydration is governed by the fineness of the cement. So this is the importance of fineness of cement. Since more surface area is available for chemical reaction, so the reaction is fast. Rate of hydration is fast. This results in greater strength development. Now, if it is fine beyond a certain limit, means if the cement is fine beyond a certain limit, its cementative property reduces due to prehydration by atmospheric moisture. You just see this, that we were saying that finer the cement, then rate of hydration is more and more strength. But here, if this goes beyond a certain limit, then there will be reverse effect. Why reverse effect? Because it can take, the cement can take the atmospheric moisture and prehydration will occur. When we are not using even the cement, then prehydration will occur and there will be deterioration of the cement. So that way cement should not be more fine beyond certain limit. Next is it is measured in terms of percentage weight retained on ISC number 9 after 15 minutes of sieving. So this is the method that how we measure the fineness of the cement. That if you sieve the cement on the ISC number 9, so after 15 minutes of sieving, what percentage of the cement by weight is retained, that will be reported as the fineness. Also, it is measured by air permeability method, and here it is represented as centimeter square per gram. Means the fineness of cement will be, here we will be representing it in centimeter square per gram. Centimeter square is the surface area basically for unit weight of the cement. Next is the setting time. What is setting time basically? The phenomena by virtue of which the plastic cement paste changes into hard mass is called as setting time of cement. Means when we add water to the cement, then it turns into plastic stage, but with time it hardens. So when it loses its plasticity basically and becomes hard, then it is called as setting time. Setting time are of two types basically: initial setting time and final setting time. Initial setting time is the time at which the cement paste loses its plasticity after addition of water, basically is initial setting time. What is final setting time? Final setting time is the time corresponding to the paste becoming a hard mass basically, and it is known as final setting time. The mixing, transportation, placing and compaction of concrete must be completed within the initial setting time of cement. This is the importance of the setting time, that all operations, all concreting operations should be completed before the initial setting time. If it goes beyond, our concreting operations goes beyond the initial setting time, then it is of no use, because now the paste is getting hardened basically, and you will not get the desired results basically. Now next property is soundness of the cement. What is soundness? The phenomena by virtue of which cement does not undergo large change in volume when treated with water is called soundness. Means change of volume on addition of water is the soundness. An unsound cement will disintegrate due to volumetric changes caused by the presence of free lime and magnesia in cement. Means these two things, these two compounds are responsible basically, these two materials are responsible for causing unsoundness of cement. These are lime and the magnesia. Now next property is compressive strength. Strength of cement in compression is judged by finding the compressive strength of cement mortar. What we do for that? Cement and sand mortar in the ratio of 1:3, 1 part cement and 3 part of standard sand is used, and cubes of 7.06 centimeter by 7.06 centimeter by 7.06 centimeter are prepared. They are cured and then tested. So whatever strength we get after testing of these cubes, that is reported as the compressive strength of the cement. Now next is heat of hydration. What is heat of hydration basically? Chemical reaction between cement and water is the exothermic reaction. Exothermic reaction means the heat is generated, heat is evolved, and this process is called as the hydration process. This chemical reaction is called hydration process. The cement chemically reacts with water and heat is generated. This heat is called as the heat of hydration. Means the heat evolved in the hydration process is called heat of hydration. The disadvantages of this heat of hydration is that if we are doing mass concreting like in dam construction, so this may cause the heat, due to the heat basically the stresses will generate and there may be cracks in the structure basically. So heat of hydration should not be much basically. Now next property is specific gravity. That what is the specific gravity? A specific gravity of the Portland cement is about 3.15. Specific gravity is not an indication of the quality of cement basically. That it doesn't give the indication of the quality basically. It is used in calculation of the mix proportions. When we do the design mix basically, there this property of the cement will be used. So in this discussion, so here we discuss what is cement, how cement is manufactured, what are the ingredients of cement, what is the chemical composition of cement, the effect of different chemical compounds in cement. Then we discuss the properties of cement. Basically we discuss here the physical properties of cement. Thanks for watching and listening.